Introduction to polynomial functions. A shipping container in the shape of a rectangular solid must have a volume of 84 cubic meters. Let it be this a fact. The client tells the manufacturer that because of the contents that he is going to put on the container, the length of the container must be 1 meter longer than the width, and the height must be 1 meter greater than twice the width. What should be the dimension of the container be? How do you entertain such kind of real-life problem using functions? How do you solve this kind of problem in real life without functions, without expressions? Pause the video and think. Can you solve this problem without function? Okay, let's move on. So the client wants to redesign the shape of the container or the dimension of the container in a way that the length is 1 meter longer than the width. Okay, let's just roughly draw. Okay, let it be this is the base. Okay, let this is the base. Okay, let me. Okay, this is the base. So the length, let it be this is the width. Okay, let it be this is the width, that is x, and the length is 1 meter longer than the width. So let it be this is the length, which is 1 meter longer than the width, and we say that this is already the width. Okay, so let it be x. Now, and the height must be 1 meter greater than, okay, this is the height or the height, it is 1 meter, let it be 1 meter. Okay, let's use different color. Okay, this is the height, which is 1 meter greater than 1 meter greater than twice the width, twice the width. So we already let the width is x. Okay, so this is the dimension of the container. Okay, let's draw it like this. Okay, okay, so this let it be this is the dimension, or this is the redesigned shape of the container. So in order to find the volume, or the volume here it's already given. Okay, the volume is given. So the volume here is the product of the area of the base, the area of this base, which is length times width. Okay, which is length times width. This is the length times width, which is x times 1 plus x times the height. Okay, as you know, volume is length times width times the height. Since it is a 3D figure, this is the prism, it's one of the prism. So the height is already given in with the expression 1 plus twice of x. Okay, whenever you solve this problem, to find the value of x that makes this expression true, we exactly determine the value of the length, the width, and the height. Okay, the height in this case is 1 plus 2x, and the length is 1 plus x, and the width is x. Okay, so thank you for the expression, thank you for polynomial function. So for whatsoever the value of x, okay, this is indeterminate, or the variable, whatsoever the value of x, this is just a machine. Okay, this is a machine on a paper. So for whatever value of x you want to redesign, this will help you to solve or to make any kind of shapes, okay, with this context, with this format with this kind of shapes. Okay, so with this one I'm going to introduce you polynomial function. This is in mathematics, this is a term we have here. Let it be this is one term. There you have, of course, another term. There you have another term. Okay, if you just consider only one of the term, this one or this one or this one, okay, so when we combine them and rewrite this as a sum, those are called terms and monomials. So the sum of the monomials, when you multiply this one, okay, when you multiply this one, let's do this one. When you multiply this one, you have x into 1 plus 2x plus x is 3x plus, when you just distribute, I'm just distributing, this is 2x squared. Okay, so when you multiply this one, x into 3x squared and 2x cubed. Therefore, in mathematics, these are called terms. These are monomials. Okay, these are terms. The sum of the terms gives you a polynomial function. In this case, it is trinomial, since it's binomial trinomial. So when you combine many terms, it's called polynomials. Okay, polynomial. So let's define the term polynomial. Okay, polynomial functions or polynomial functions. So in this case, there you see the word poly. Poly is a Greek word. It's just to mean money. And there you have nomial, means this is it's of course nomi. That's a Latin word, I think, to mean name. Or in mathematics, we call this as term. Okay, in Latin it's called a name, but it's just in mathematics. Let's be represented as a term. So it's many terms. A combination of many terms gives you polynomial. But we specifically will define, because you do have single variables and you may have multi-variables. Function is a relation. It's special types of relation where for every input you will have one output. Okay, so it's a very specific type of relation. Okay, so let's see the forms of polynomial function. So polynomial function, let it be P. It could be represented by capital P or capital P, H, T. It's convention. P of x is defined as an x to the power of n plus an minus 1 x to the power of n minus 1 plus an minus 2 x to the power of n minus 2 plus a1 x or a1x. Actually, this is not the end, so I should put here this continues, okay, until you get a1x, okay, a1x or a2x squared plus a1x plus a naught. Okay, so this is just single or for one indeterminate. We have only one variables here. We have one variables, okay, one variable or one indeterminate, just that is x. But we can also have two variables involved in it. That also can be a polynomial function. Okay, so in this context, look at the power. The power should be n should be elements of positive integer. Okay, it should be positive integer. So the exponent should always be positive integer. It shouldn't be rational number. It shouldn't be fraction or negative also. We can't have that. So this is an exceptionality, the power or the exponent. Okay, so as you can see here, look at this one. As you can see here, this is an, you have n, So you have n minus 1, you have n minus 1, you have n minus 2. You will have exponent as n minus 2. When it is 2, you will have here 2. When it is 1, you have here 1, and so on. Therefore, we can express this as a sum. We can express this as a sum where k starts from 0 up to n of an to ak. Okay, let's ak to x to the power of k. Okay, we can express as a sum because this can be, this is one of the term, this is one of the term, this is another term. So you have the sum of the terms gives you polynomial. Polynomial means is many terms. Okay, many terms. All right. So polynomial functions in real life has or it's involved in different disciplines. Okay, and we have polynomial function in physics, in chemistry, in even economics and social sciences. So we have polynomial functions. There are real life phenomena where polynomial functions can represent that real life cases or real life situations. So we can apply real life polynomial function to solve real life problem as one of the functions. Okay, as I said, function is a machine on a paper. Okay, any machine has a purpose, so our function has a domain. It's just integrated. Therefore, we can represent a polynomial like this. In this case, as you can see, n is the largest one. Okay, so n is the largest because it's decreasing. As you can see, n minus 1, n minus 2. Those are, of course, we'll see in the next videos about those. So in this case, an minus 1, an minus 2, these are up to like a1. These are coefficients. Okay, these are coefficients. Of course, we will discuss that in the next videos. Okay, so this is polynomial functions, and this is just single examples of many of the polynomial functions.